Okay, all right, we're gonna try this for a second. Oh yeah, that's good. So hi, I'm Phil. I'm a professional developer nerd type person. I'm an engineer on the big data team here at Moz. And what I'm gonna talk to you about, if you dare, is the future of Mozscape. But first, hello? Huh. There we go. This is Joel. He's an all-around friendly Viking on the help team. He's going to be helping out with the presentation a bit. But Mozscape, many of you know it as OpenSci Explorer, but it's directly available as an API for mashups and like. Here's OpenSci Explorer in its shiny, awesome new skin. If you haven't seen it before, it's a search engine for backlinks, although I think everyone here is probably familiar with it. You stick your URL in there, and we'll show you everyone who points to you. And we'll let you do a little slicing and dicing on the way. Our real claim to fame, though, in addition to the backlinks, are these guys, page authority and domain authority. They represent our best keyword-agnostic guess about how well a given page or domain is going to rank highly in search engine SERPs. They also represent one of like a dozen or so machine learning secret sauce kind of metrics that help set our index apart. The index is pretty large. We begin with hundreds of terabytes of raw crawler information. That's like maybe like 100 iPhones. And we distill that down into a single 15 terabyte artifact, which we serve by an API. Along the way, we're going to pick up about 90 billion URLs and 900 billion links. 900 billion links! In the immortal words of Kung Pao, enter the fist, that's a lot of links! That's pretty cool, but we've known for a long time that we could do better. A lot of really smart people have iterated on this thing for a long time. And all of the low, medium, and high-hanging fruit have all been eaten. And yet, the demand for a bigger, faster web index remains. Our work is never over. We need a change. It is my happy task to work with a small team, who's like sitting right there, to architect and implement this new change. And that is kind of what I want to talk to you about right now. First, we have to talk about where we're at here. I already mentioned that we are very well tuned, right? We're not going to beat our existing system. We're not going to make it bigger, make it faster by reusing the existing designs we have. It's not going to just magically get better, right? We need a key insight. The key insight begins here. Mozscape is a batch process. Now, what do I mean by that? Batch processes are really, really simple programs that maybe you can make them scale, right? Ours happens to be, we begin with a whole bunch of this raw 100 terabytes crawl stuff. We do a whole bunch of map-reduce type math to it. Don't worry about what that is. And then we come up with this 15 terabyte thing that we offer with an API. And then we start over, which makes a lot of sense in a batch process world. It keeps everything simple, keeps it all clean. The only problem is it's kind of slow. Every time we go around this loop, every time we make a new index, it takes a couple of weeks. A couple of weeks? Which is maybe okay for skunk work projects that we're just kind of feeling out, but this is grown. It's bigger now, wants to be better now. And actually, our existing big data team has done a very awesome job getting these things out as fast as possible. I think we had like one every week in the month of June. That was awesome, right? But still, come on. Every time we build this new index, every time we turn this loop over, we throw out all of those answers from the last round. Now we're starting getting closer to that key insight I mentioned. Maybe we shouldn't do that. Think about the internet as a whole, like by volume of pages, say. How many of you think that more than half of it changes in a month? Show of hands. Yeah, right? Who thinks less than half of it changes in a month? Woo! Who's tired and doesn't want to vote because it's early? Yeah, I appreciate transparency. Yeah, depending on how you count, and especially if you want to say things like timestamps in CSS, version counters at the bottom of your markup, stuff like this, if these don't really count, maybe like a lot less than half. And so, but for sake of argument, let's just say half. If we only knew which half stayed the same, we could hold on to it and get a 2x improvement right there. Right? So that is going to be our key insight. Our team believe that most of the internet is going to be slowly changing enough. I'm not talking about your DA10 sites or even like DA7 or above. It's all that other stuff way down there, right? That's slowly evolving. We're going to be able to save that. That's one of the weird things about the internet. It's an organic phenomenon, which means that many of the qualities about it follow what's called a power law distribution. Even if the name is new, you know what this idea is. It's the many and the few. It's the 99% and the 1. The majority of links on the internet only go to a handful of pages. The majority of updates only go to a handful of sites. So, okay, how do we act on this realization? Well, now let's try this. Suppose, hypothetically, that we have access to a massively horizontally scalable ordered key value store. Don't worry, that's okay. Don't care about that is. But suppose that we give each row in this store a page, and we store some stuff in there, like our page authority or inlinks or whatever. Every time a web crawler, such as this one from Halo 4, shows up, it's going to crawl a page, grab a bunch of outlinks, links going away, right, and shove them in here. And then once it's gone off and done its crawly thing, presumably somewhere else, something else is going to snork awake. It's going to see all these new inlinks, and it's going to shuffle them around to where they need to go. If I have an outlink to you, you get an outlink from me. So I need to go find you and say, oh, you have an inlink. OK. Maybe actually a couple dozen things snork awake. One that distributes inlinks, one that updates page authority, one that deals with anchor text. You get the idea. At any time during this process, OpenSci Explorer or an API client, anyone in particular, could come by and ask for the content, the current state of affairs for this single row. And depending on when they swing by, maybe they get the freshest stuff, but maybe it's a little bit old. However, if everything is working well, then the idea is that the time it takes to go from the crawler arriving to everything's being fully indexed should be pretty fast. Surely less than a day, probably 15 minutes or so on like median time, which would be a hell of a lot better than weeks. This is maybe not as simple as I'm painting it out to be. There are 10,000 weird little things that happen to programs when you try to run them on the trillion item scale. Joel, what do 10,000 details look like? Yeah. Imagine these running all around you all the time. And concretely, obviously, speed is a major concern. And I mean both the throughput of indexing, how many pages you can get a second, and the latency, that 15-minute number I was talking about. Reliability is a critical concern. If those things that are supposed to snork awake, if they don't snork, well, then things start breaking down, right? And so things always have to work. And when I say always, I mean always. Did the network blip? It still works. Did the power on the machine fail? Still works. Did dinosaurs rampage the data center? It still has to work. These are the kind of things that we end up wrangling. Another concern that we didn't really appreciate fully the first time is that this effort must be reusable. Mozscape's existing code base is a little messy. Actually, it's kind of a lot messy. Some guys over here can testify to that. And that maybe is OK. Except that it's hard to add new things to messy code. And we like new things. I love new things. We want new things. So this time around, we're going to separate the how of what we're doing from the why and the what. And we're going to put the how in an open source tool that right now we're calling Meerkat. When it's finished, we'll kick it out the door. You can download it. It'll be great. Standing on the shoulders of giants, me and my one other dev, right? We're not going to reinvent massively scalable databases from the ground up. That's kind of insane. So we're going to build on something called HBase. It's an Apache Hadoop project. It's that massive ordered key value store thing I mentioned earlier. and our own internal framework called Plines, which is a job thing that our analytics team actually developed internally. It's super awesome. I imagine we'll be open sourcing that as well in like a couple weeks. HBase is an interesting choice for a couple of reasons. It has all these great things, row-level transactions. It has triggers and stored procedures in the form of these co-processor things. But it's also got this versioning feature which turns it into a frickin' TARDIS. Yeah! Now, what I mean by that is HBase is a clone of an existing package called Bigtable. That's Google's private internal storage engine. If you've ever written a Google Apps kind of thing that's hosted in their infrastructure, you've probably used Bigtable, whether you knew it or not. And like Bigtable, every piece of data inside HBase not only exists in some row and column, but also on this third dimension called version, right? And versions are usually taken to be timestamps. So not only can you inspect the state of your data as it exists right now, you can take a peek at it back in the past, which essentially means that charts like this one get super silly easy. What we're seeing right here is domain authority plotted over time for a handful of sites. But this could also be the in-links themselves, seeing whether a link appears or disappears, when that happens. Our analytics application right now does something very similar to this feature. That's where the screenshot came from. But it's only for a handful of metrics on a couple of domains that you opt into, that you choose to follow around. Using this Meerkat system, maybe we can get drill downs for everything everywhere. That would be super great. Obviously, it's hard to talk about performance confidently before the thing is finished, but we have pretty good reason to believe that we'll be able to incorporate every new wave of crawler output within a couple of days to a week. Now, because it's this kind of rolling release cycle thing, there aren't any releases anymore. It's just always there. It's like Google itself. It's just always there. Nobody ever says anything about, oh, Google released an index, right? That doesn't happen. Still, we go from weeks right now to a couple of days, and I completely believe that we'll be able to push this down to hour scale eventually. Oh, wrong one. That is just extra super hot great. But since we have this Ferrari, let's talk about what else it can do. So what happens if you take machine learning techniques, apply them to fresh time series data at massive scale? Anybody? Something wonderful happens. Predictive modeling! Predictive modeling is the idea that with enough processing power and enough fresh data, not only can you predict facts about the present, you can see into the future. So, total blue sky example, don't go looking for this just yet, but suppose we craft some JavaScript for you, you run it on your sites. You send us all your traffic, or just like your aggregate metrics, stuff like this, right? Just like the Google Analytics type stuff. We feed it into what's called a Markov chain and mix it in with a bunch of other signals and information we have about your site. And then we tell you how much traffic you're gonna get tomorrow. Oh my God, right? They're hacking the matrix here. That would be super sweet. I'm personally really excited about that. As far as a stats problem goes, this is pretty cool, but it fits into a mold that a lot of other things kind of fall into, called probabilistic graphical modeler, PGM. And the cool thing about these is that they are all soluble with a certain kind of message passing algorithm. You can Google this stuff up if you really feel like learning some hardcore stats. But the point is that if you can solve it with these kind of message passing type things, then it's going to project pretty nicely onto this distributed model. I think that's pretty sweet. I'm excited. I hope you're excited. Look for this in the next couple of months, kind of Q3, kind of Q4 thing. I think that's all I have. Thank you so much.